Okay, question 9 looks really complicated because you've got pulleys and things like that, but really it's going to be checking you're learning about work. So we know fat, wobbly dinosaurs. The person pulls down on the rope. So they're going to the force times distance there equals the work that they're doing. And then work is going to be done against gravity, FD there. So the person pulls down the rope to make it rise 1.2 meters, no problem, no unit change. The work done against gravity is 1,800. Calculate the weight. So the weight is the force. So divide both sides by distance. And we end up with force equals work over distance. So 1,800 divided by 1.2 equals 1,500. So that's quite nice. Go on to the next part. The efficiency of the system is 64%. I've taught you to just use 0.64 because then you can get rid of any rearrangements with the 100%. So it says calculate the work done by the person. Okay, so we're after this. So let's put an X there. The work done against gravity on the barrel, well, it says that was here, 1,800. So if I go back to that question, I now know 0.64 equals 1,800 over X. So now let's get X from underneath here. So if I times both sides by X, so X multiplied by 0.64 equals 1,800. X is going to equal 1,800 divided by 0.64. So you've got a pretty tricky rearrangement there. Now you could do it leaving the 100 in there, and that's absolutely fine, but it just makes it more complicated. So there we go. So the work done by the person is the work done by gravity divided by the efficiency, and then we get that answer there, 2,812.5. Some energy is wasted due to friction. Okay, so suggest another reason. So I can't talk about heat energy due to friction. Why some energy is wasted in using this pulley system. So some energy is going to be wasted because there's an additional mass from the ropes and pulleys. This system's got other masses in there in terms of the force times the distance, so additional mass and additional weight. Some work is done increasing the elastic potential energy stores of the rope. The ropes are not perfect, they've got some stretch in them. Tricky one, that. Okay, next part. Students got the equipment. Devise an experiment to investigate how the efficiency of the pulley system. So if I just get this ready, we know efficiency. I'm going to have a force times distance there, and then I'm going to do work against gravity to have a force times distance there. This, I'm going to have to put more work into here than here because I've got friction on the gear, on the pulleys and things like that. And it says divide an experiment to calculate the efficiency. Well, I now need to do the work, which is the force times distance there, and I can see I've got a spring balance. So if I now pull on that spring here, I know the weight of what the cubes of metal. I need to find their masses and then change those to a weight. So I can just put them on a balance that measures in newtons. I've got a meter ruler to measure the distance that I raise it and the distance that I pull the rope. So here we go. We can see with changing the weights. I'm going to change the cubes of metal and their weights. So let's say that's 1, 2, 3, 4, 5 newtons. I always say give them a decent range. We're then going to pull that up and measure the distance times there, and I'm just going to change that from force to their weight. So their weight times the distance, that's going to be the useful output. This is going to be the total input. So efficient, useful tools. Or you could have looked at the equation before in terms of work done, but I'm going to do it this way. Okay, so now let's get ready for this 6 marker. So the first part, weigh the blocks with a Newton meter or put them on a scale that measures in newtons. We need at least 5 results. 1, 2, 3, 4, 5, 6 newtons. There we go. Got to calculate the work done by the student and the work done on the cube. So work equals force times distance. So we're going to need a Newton meter to measure the force and then a ruler to measure how far I've pulled the ropes. Attach the weight to the hook A and a Newton meter to B. So I'm going to label that, and I've drawn it on there. All right. In fact, I haven't drawn a cube, so let me just show a cube there. The student pulls on point B with a Newton meter, and they measure the distance the rope moves using a ruler. So we get the force by pulling on the spring balance. and we get the distance by using the ruler. We also measure the height that the weight is pulled up. Efficiency equals useful over total, so the work on the block divided by the work by the student. And I can see here I've just put force times height and force times distance. I could do weight times height, actually, would be probably better there, divided by the force times the distance, and that's my efficiency. And then we could put in there repeat and calculate a mean for each one, or draw a graph of the work versus the student versus the work done on the block. So I can sketch a graph and check the relationship. So tricky question, and I'm going to rub all of this out and neaten that up. But what it's saying is, find the weights of some cubes, add them here. Get your spring balance, attach it here. You pull on that bit and get the force times distance. This is now your weight times height, and the one over the other in terms of efficient useful tools gives me the efficiency. Any problems with that, give me a shout, because it's a tricky question.